Let's look at example 8. Mr. Prospero has been teaching Algebra 2 from a particular textbook at Remote Isle High School for many years. Over the years, students in his Algebra 2 classes have consistently scored an average of 67 on the end of course exam, which they're calling EOC. This year, Mr. Prospero used a new textbook in the hope that the average score on the EOC test would be higher. The average EOC test score of the 64 students who took Algebra 2 from Mr. Prospero this year had a mean of 69.4 and a sample standard deviation of 6.1. We want to determine whether these data provide sufficient evidence at the 1% level of significance to conclude that the average EOC test score is higher with the new textbook. All right, so let's notice first of all that our status quo is that the average grade, the mean grade, is 67. So that's going to be our null hypothesis, that our mean is 67. All right, but he wants for the scores to go up based on this new textbook. So our alternate is going to be that the mean is greater than 67. So let's put that down first. All right, so our null hypothesis is that mu, our mean, is 67. And then our alternate hypothesis will be that mu is greater than 67. And then alpha, in this instance, I believe was 0.01. Let's look back here. 1% level of significance. So that's 0.01. Now let's notice this is a right-tailed test because of our alternate hypothesis. Since we're using the observed significance, or the p-value, we're going to go straight to finding our test statistic. All right, so our test statistic, we're going to have z equal, we need our sample mean minus the 67 on top. So let's see, our sample mean was 69.4. So we'll have 69.4 minus our 67 divided by, now we want our sample standard deviation. We didn't have the population standard deviation, divided by the sample size. So let's see, our sample divided by the square root of the sample size. Our sample standard deviation is 6.1. Our sample size is 64. So 6.1 divided by the square root of 64. All right, and let's stick that into our calculator. So our 69.4 minus 67 gives us 2.4. And our 6.1 divided by the square root of 64 gives us 0.7625. And then if we do that division, it's 3.148. Okay, so now let's find our p-value. Now let's realize our alternate is a greater than. And when our alternate is a greater than, we're going to first look up 3.148 using our Excel function. But we've got to subtract it from 1 to actually find the area to the right of 3.148. Recall, since it's right-tailed, we're going to find the area, if this was 3.148 right here, we're going to find that area to the right. So looking things up on Excel gives us the area to the left. We've got to subtract from 1 to find the actual area. All right, so let's look things up on Excel. Equal norm.s.dist, and it was 3.148, and the word true, and we get 0.999178, or let's round to 4 decimal places as our homework tends to do, so 0.9992. Now for our actual p-value, we want to subtract that from 1, which is going to give us 0.0008. All right, so now let's compare. Recall, if the p-value is less than alpha, which it is here, we reject the null. So we can reject the null hypothesis. That means we're embracing this alternate, and the alternate tells us the mean for the test now is certainly greater than 67. So, there is sufficient evidence, p-value equal 0.008 to reject the null hypothesis. The new test scores do in fact appear to be greater than 67. And there we have it.